Ladies and gentlemen, I'm going to talk to you a little bit about a question that humans have been asking for thousands of years. Are we alone? And I'm not talking about those humans that walk around talking to an imaginary friend because they like intelligent conversation. We're going to look at some other planets and see if there may be life elsewhere besides the Earth. So the theory tells us that planets form out of the so-called debris disk of material that's left over once a star is born. And over time, little pieces of this debris disk coalesce into larger and larger chunks, basically, until they become big enough to become planets. Now, we know that there are three main ingredients that are required for life to exist. That's liquid water, the conditions so that organic molecules can form, and some form of energy that can sustain metabolism. Now, since the solar system is in thermal equilibrium, there's a well-defined distance away from a star where the temperature would be such that liquid water can exist, all the way from just below boiling point on the one hand to just above freezing point on the other hand. And that region is called the habitable zone. And that's where theory says we should look for the signs of life. Now, we'll get back to that in a little while. For our solar system, the habitable zone stretches from just inside the orbit of Venus to just outside the orbit of Mars. Now, the temperature on Venus today is hot enough to melt lead, so finding liquid water there is very unlikely. And that's not because it's not in thermal equilibrium, it's because Venus has a very, very thick atmosphere and basically has a runaway greenhouse effect going on. So let's skip to the other end of the habitable zone, to the planet Mars. Now, some of you may have heard that we had a rather spectacular landing on the surface of Mars in August of last year. And if you were here yesterday, you saw a few snippets of a video of that landing. So here we go.
Green is started.
Even nerds can get excited. Well, there she is. Curiosity on the surface of Mars after traveling around 500 million kilometers in 8 months. Curiosity carries 10 very sophisticated instruments, and it's basically a roving chemical laboratory. And one of the main questions we wanted to answer with this machine was whether the conditions on Mars were ever such that it could have supported life. Now, Curiosity carries a drill with which it can drill some holes into rocks so we can look at the interior of the rocks. And here you see a photograph of the first two holes ever drilled into a rock on a different planet. Curiosity then scooped up some of that gray material that came out of the rock and placed it into two of the instruments inside the belly of the rover for further analysis. And the results very clearly showed that the conditions in Gale Crater where we landed could have supported life. In fact, humans would have been able to drink the water in which those rocks formed. But that's not all. This series of images taken with one of our spacecraft orbiting around Mars shows those streaks forming during the Martian summer and then retreating and disappearing again at the end of the summer. The theory is that those are seeps of briny water that form where the ice in the Martian crust is close enough to the surface that it can actually melt during the summer. So the important point is there is liquid water on the surface of Mars today, even though it may be in limited quantities. But this conference challenges us to reset and rethink. So let's leave the comfort of our habitable zone and venture further out in our solar system to the next and largest planet in the solar system, in fact, Jupiter, shown here with its moon Europa in front of it. Now, a close-up look of Europa shows a surface that has very few impact craters on it. And in fact, what that means is that it's a relatively young surface. In fact, the surface of Europa is dominated by these linear features that appear like cracks. The entire surface of Europa is in fact an ice crust that's between 10 and 30 kilometers thick. And underneath that ice crust is a liquid ocean, most likely salty because it has a magnetic field, so we can tell it has to be salty. And it's estimated to be about 100 kilometers deep. Now, keep in mind, on the Earth, the deepest point in our ocean is only about 11 kilometers. So what keeps this ocean in its liquid state? Well, it's tidal flexing. As Europa orbits around Jupiter, the tides that this large planet forms inside this moon actually keeps the ocean in a liquid state. So here is the relative sizes of Europa and the Earth. Europa is slightly smaller than our moon. Also shown by those two little water bubbles is the relative amount of water on these two bodies. So even though Europa is much, much smaller than the Earth, it may very well be the body in our solar system that has the most water on it. So liquid water, salty water, and heat. Definitely a place we should go look further for the signs of life. Let's move out further to the second largest planet in our solar system, Saturn. Shown here with its spectacular rings as photographed by NASA's Cassini spacecraft. Saturn has more than 60 moons around it, and one of them in particular, called Enceladus, turned out to be a very interesting object. On one of its orbits around Saturn, Cassini took this picture of Europa that shows what appears to be 4 plumes coming out of the South Pole region of that moon. So we challenged our navigators to bring the spacecraft as close as possible to that moon so we can take a better look at those plumes. And they responded by flying 25 kilometers above that surface of that moon. Not bad, considering that Saturn is more than 1 billion kilometers away from us. And they actually flew the spacecraft through those plumes. So we were actually able to measure that those plumes are actually geysers of water vapor that shoot out of that moon to several hundred kilometers in the air, by the way. And not only does it contain water vapor, it also contains complex organic compounds. Another world where we have liquid water, organic compounds, and heat from tidal flexing. You can see here a close-up of that moon. The plumes come out of those linear cracks in the bottom of this moon. So yet another place that we should go back to and look for some signs of life. These examples illustrate that there are as many places in our solar system outside of the habitable zone where we should be able to find life as there are inside the habitable zone. But what about all the space outside of our solar system? Could there be planets out there that could harbor life? Well, it's unfortunately very hard to make good pictures of planets that are very far away. Here is a picture of the Earth. Now, there's nothing wrong with your eyes. It's a crappy picture. It's 160 kilometers resolution to prove a point. If you were to take the Earth and you move the Earth to the nearest star to our sun, a tiny 4 light years away, you would need a telescope 15,000 times the size of the Hubble Space Telescope to make this crappy picture of it. So there's no way we can launch a telescope that size. By the way, the mirror would cover the Greater London. That's how big that telescope is. But fortunately, there are indirect ways in which we can find planets around stars. One is shown here. Every time a planet comes between us and its parent star, it blocks a little bit of the light from that star out. So the star appears to go dimmer for a little while, and then it comes back bright again. And this process repeats itself every time when this planet comes between us and its parent star. So NASA built a special 100 megapixel camera, put it in a medium-sized telescope, and launched what is called the Kepler mission in 2009. Now, Kepler stares at the same 150,000 stars every second and looks for those little dimming events to determine whether there are planets around those stars. And as of January this year, the Kepler team announced that they have found 2,740 planets around more than 500 stars, ranging from ones much, much larger than our sun to ones only about a tenth of the size of our sun. Now you might say, why 500 out of 150,000? Keep in mind, Kepler can only see those planets that come between us and their parent stars. Only certain orbits will do that for us. There may be many more orbits, planets out there, that are just such that they don't come between us and their parent star. Now, I know there's some people that say there are lies, there are damn lies, and there are statistics. But if you take the statistics of random orbits into account and combine it with the results from Kepler, the team estimates that there are at least 50 billion planets, billion with a B, planets in our Milky Way galaxy alone. And of those, 500 million of them are in the habitable zones of their stars. Suddenly, our solar system doesn't look nearly as unique as it did 10 minutes ago. So the question, are we alone? I don't know. I'll let you be the judge of it. All I can say is that I hope that in my lifetime, we would see somebody find a biosignature somewhere else in the universe. Thank you for your time.
So Jakob, if we've established that there's likely to be water up on Mars, what do you look for there next?
Well, we want to look for possible signs of past life. So as I said, Curiosity carries 10 very sophisticated instruments, instruments that would be sophisticated if they were in your laboratory on Earth, in fact. And so what we're going to do is we're going to drive up this mountain where we landed. There's a mountain that's about 3 kilometers high, very close to where we landed. And we're going to drive up that mountain. That mountain is made of layered material. So layered material means we're going back in the history of Mars. So we can look over the history of Mars, sample rocks as we go, to see if there was ever a time in Mars where we could find maybe signs of past life.
So Google talks a lot about moonshots, but Elon Musk with SpaceX is talking about doing a Mars shot. His Dragon going up to the space station, he sees just as a learning experience because he wants to settle Mars.
Correct.
When's that going to happen?
Well, Elon from the beginning said that the reason he's building rockets is to go to Mars. In fact, we work with him. Since we know how to land there, he wants to go there. He has the rockets, we don't. That sounds like a pretty good partnership. There are lots of obstacles to overcome. Going there is not the hard part. Bringing people back is the hard part, especially if you're going to land on the surface, because you have to create the technology to build a rocket on the surface of Mars so that you can launch people back into space and bring them back. Now, people like me might actually volunteer to just go there and stay there, but most people would want to come back. I bet, though, if Google decided to have Zeitgeist on Mars, a lot more of people would like to go there. So.
We'll be taking a list of early volunteers after this. Thank you very much, Jakob Van Zyl.
You're very welcome. Thank you very much.